Okay, so today we're going to get another prerequisite for the course, and it's probably one of the most important lessons you can learn in algebra. It's going to follow you through pre-calculus, calculus, and beyond. Very, very powerful tool, and that is factoring. And I know that my high school kids and college kids in the past, they've always really struggled with this concept. Guys, you really, really need to get a hold on this, understand it, ask questions, post messages, get a hold of me if you're struggling with this, because you really, really, really have to understand factoring to move forward. When factoring, the first thing you should always do, not only should, must, the first thing you must always do in factoring is take a look at that polynomial and ask yourself, do all of the terms have something in common? If so, you must factor out that greatest common factor first. If you don't, there are ways, a lot of times, to still get to the right answer, but many times a student's going to mess up getting to that step. So always look for greatest common factor. So the process of taking something that's common out is called factoring. Unless otherwise noted, when you're asked to factor a polynomial, you can assume that you're looking for factors that have integer coefficients. So most of what we're going to do is involve integer coefficients. Later on, we'll get into factoring that are not integer coefficients. If a polynomial does not factor using integer coefficients, then it's prime, just like the number 7. The only two numbers that multiply together to get 7 are 1 and 7. So we consider 7 prime. We can do the same thing with polynomials. The number 6. We don't say 6 is prime because 6 has factors of 1. 1 times 6, that's 6, and 2 times 3. So because 1 and 6 are not the only two numbers that go into the number 6, we call 6 composite. It's composed of other things. So again, a polynomial is prime if there's no way to break it up into factors. For instance, x squared minus 3 is irreducible over the integers. Polynomials with common factors, 2 of 3 here. Over the real numbers, this polynomial factors out. So that x squared minus 3. I told you it doesn't factor with integer values. However, we can factor it still using real numbers, but these numbers aren't necessarily integers. A polynomial is completely factored when each of its factors are prime. For instance, if I had the polynomial x cubed minus x squared plus 4x minus 4, it factors into x minus 1 times x squared plus 4. And we're going to talk about how we got that here in a little bit. However, if we wrote that as this next polynomial, if we wrote this polynomial, x cubed minus x squared minus 4x plus 4 as x minus 1 times x squared minus 4, this one is not completely factored. And the reason it's not completely factored is because x squared minus 4 actually factors further. So factor that polynomial completely, the final answer would be x minus 1 times x plus 2 times x minus 2. The simplest type of factoring involves a polynomial that can be written as a product of a monomial and another polynomial. This has to do with factoring out the greatest common factor. So if I was to use a distributive property for a times the quantity b plus c, that would give me a times b plus a times c. So to reverse that is called factoring. So as we look at the polynomial ab plus ac, we can ask ourselves, okay, what do those two terms have in common? Well, they both have an a in it. Got an a here and an a here. So what we can do is we can factor that a back out, which would give us a times b plus c. Again, removing any common factors is the first step in completely factoring a polynomial. Not sometimes, not most of the time, but always factor out the greatest common factor first. So, a couple examples here. 6x cubed minus 4x. Well, we look at 6x cubed minus 4x. We're going to jump down to the bottom. And we look at that. And if you look at just the numbers, we have a 6 and a 4. Well, the number 2 is the biggest number that goes into both 6 and 4. And then we look at the variables. Well, I have a variable that is x cubed, and I have another variable that's x. So both of those terms have x in them. So we write the x down as a common factor. And the next thing we want to look at is say, okay, well, on the x's, which exponent is the smallest? Well, the first one has an exponent of 3, and the second one has that unwritten exponent of 1. So the smallest exponent is 1, which means I'm allowed to factor out a 2x. So when I take a 2x out of 6x cubed, basically what you're asking yourself is, okay, so here's my 2x. If I take 6x cubed and divide it by 2x, what would be left? 4. What would I have to multiply 2x by to get 6x cubed back? Well, 2 times 3 would give me the 6, and x times x squared would give me x cubed. And because I'm taking a 2x out, I'm factoring out of both terms. I'm factoring that negative 2x out of that second term and asking myself, okay, so if I take a 2x out, what's left? Well, 2x times 2 is in fact 4x. So removing that 2x gives us 2x times the quantity, 3x squared minus 2. Example B. I have a negative 4x squared plus 12x minus 6. Well, here we have a trinomial. We have to ask ourselves, does this trinomial, does this polynomial with 3 terms in it have anything in common? Well, they don't all have variables in it. So we don't have to worry about the x's because that last term 6 does not have an x to a power 1 or higher. And so we look at it and say, well, let's see, 4, 12, and 6. Well, I think they might have messed the problem. Let me take a look at this problem real quick. It's supposed to be 16. So let me change that to 16 to make it match the work that they actually did here. Sorry about that. I've done this in the past. Okay, so I have a 4, a 12, and a negative 16. All right. Well, 4 goes into all of those. Now, when I factor out a 4, I also have to look at that leading term. So this right here is a leading term. Remember, the leading term, that's an I. A leading term is the term that has the highest exponent. And when factoring, it's so much easier to factor if that leading term has a positive coefficient. So what we're going to do is we see that negative 4, 12, and 16, negative 16 all have a 4 in common. But because the leading term is a negative 4 coefficient, we're actually going to factor out a negative 4. So we have to ask ourselves, okay, negative 4 times what will give us x squared? Well, negative 4 times x squared gives us that negative 4x squared. Negative 4 times what will give me this negative 3x? I'm sorry, negative 4 times what will get me to 12x? Well, negative 4 times negative 3x is 12x. And finally, how do I get a negative 16? Negative 4 times what is negative 16? Well, negative 4 times a positive 4 gives me a negative 16. And the last one looks kind of weird. Probably haven't seen something like that in a while. Remember, terms are separated by adding and subtracting. So that first piece, that x minus 2 times 2x, that's actually one term. X minus 2 times 3, that's also one term. Those two terms are separated by this addition sign in the middle. So looking at those two terms, what do they have in common? Well, they both have this x minus 2. So we factor out the x minus 2. And it's kind of hard to see. I'll draw some lines on here. If you were in class, I would actually cover them up. So think of it like this. If I was to factor out that x minus 2, so we didn't see this x minus 2, and we didn't see this x minus 2, so we factored those out. What's left? Well, clearly all that's left is 2x plus 3. And that's when we have 2x plus 3 being left after factoring out the x minus 2. There are some special polynomial forms. The more you're comfortable with these, the quicker you're able to factor. So spend some time and try to understand these. The first one is the difference of two squares. Anytime I have a perfect square, for instance, u squared, that's a perfect square, minus, we're subtracting, that's why it's called a difference of two squares, v squared. So v squared is also a perfect square. So anytime you have u squared minus v squared, it's going to factor into u plus v times u minus v. And I strongly encourage you to write it that way. U plus v, u minus v. Write that positive one down first. So as an example, we have 9x squared. 9x squared is a perfect square because if I was to take 3x and square it, 3x times 3x gives me 9x squared. So 9x squared is a perfect square. 4. It's a perfect square. It's a perfect square because 2 times 2, or 2 squared, will give you 4. So what we have done here is we have identified our u as 3x and our v as 2. And doing so allows us to write our answer as, and I'm going to say the u's and v's instead of what you actually see. I have u plus v times u minus v. Now that was one that I memorized and I've used it over and over and over. The other two are nice little tools. If you actually remember them, great. If not, there's other ways to get there. But these are called perfect square trinomials. When you have a perfect square trinomial, what that means is this trinomial factors into a perfect square. In the example, the first one is going to factor into u plus v. So if you'll notice, the first term is u squared and the last term is v squared. So when you're factoring, if you see that the first term is a perfect square and the last term is a perfect square, it is very possible that it's going to be a perfect square trinomial, either adding or subtracting. So if I had x squared plus 6x plus 9 as my example, x squared is a perfect square. It came from x times x. 9 is a perfect square. It came from 3 times 3. And the neat thing about that is that middle term, that 6x, is the square root of x squared, which is x, times the square root of 9, which is 3, but you have to double it. So x squared plus 6x plus 9 factors into x plus 3 squared. So notice that in a perfect square trinomial, all 3 of the terms are positive. If you're dealing with a perfect square trinomial in which the middle term is negative, if that middle term is negative, that is going to influence that middle sign right there. So instead of being a u plus v quantity squared, it becomes u minus v quantity squared. Sum or difference of two cubes. If I have a perfect cube plus a perfect cube, it factors. If I have a perfect cube minus a perfect cube, it factors. I'm going to go back up real quick for just a second. I want to point out up in this section right here, we have a section that says difference of two squares. And you'll notice there's no such thing as a sum of two squares. The sum of two squares does not factor in the real numbers. Okay, so when we're talking about cubes, we can have a sum or a difference of cubes, and both of them factor. So what we have here is u cubed plus v cubed. U cubed comes from the fact that we cubed u. And v cubed comes from the fact that we cubed v. What I want you to do here is notice that both of these are pretty similar. They're both similar in that they both have the u, v, they both have the u squares, they both have the uv, and they both have the v squares. So what's different about them? Well, the difference is in the signs. And a way that I've found that helps people to remember the order of the signs if I take u cubed plus b cubed and factored it, it's going to be u plus, which happens to be the same sign that I started with. So we have the same sign there, times u squared. Oh, it's now minus. So it's the opposite sign. And if you'll notice, after the uv, both of these are the same. So they both say plus b squared. So it's always plus. So when you're talking about factoring a sum or difference of cubes, if you'll remember, so same sign, opposite sign, always plus. And that will help you remember the order of the signs for factoring a sum or a difference of cubes. The factored form of a difference of two squares is always a set of conjugate pairs. Folks, get a hold of this idea of conjugate pairs. You're going to see this time and time again. So the conjugate to a plus b is a minus b. The conjugate to a minus b would be a plus b. So to get a conjugate pair, it's basically a and b are the same, and then you change the sign. One's positive and one's negative. In this case, I use u and b. To recognize perfect square terms, look for coefficients that are squares of integers and variables raised to even powers. What that is saying right there is if I had x to the sixth power, 6 is even. So because my exponent is even, that is the same thing as saying x cubed times x cubed, which means all we're saying is x cubed squared. So x to the sixth power is, in fact, a perfect square. So example A, I have x plus 2 squared times y squared. X plus 2 squared is a perfect square because it's something, and that's a very technical term there, thing. I've got something raised to the second power. Well, that's a perfect square. I also have y raised to a perfect square. So using your little formula that said u squared minus b squared equals u plus b times u minus b. I'm identifying for this problem on A, I'm identifying a plus 2 as my u and y as my v. So you can see in my final answer, I have u plus v, u minus v. And since I can't combine anything, I'm just going to leave it just like that, and I'm good to go. Example B, I have 16x to the fourth power minus 81. Well, 16 to the x to the fourth power is a perfect square. 4 times 4 will give me 16, and x squared times x squared will give me x to the fourth power. And then 81, square root of 81 is 9. So what I've done here is I've again identified my u and my v. So my u is 4x squared. My v is 9. Notice I'm not saying anything about that minus sign in front of the 9. We are talking about a difference of 2 squares. So I know there's a negative there, but the 2 perfect squares are being subtracted. So u and v are both positive here. Okay. So when I factor that, I factor it into u plus v times u minus v. So there, done. Difference of 2 squares, right? The problem is I'm not done. And the reason I'm not done is because we have to factor completely. This second term here, this 4x squared minus 9 is also a perfect square. So because 4x squared minus 9 is also a perfect square, we have to factor that piece. And this is why when I'm telling you how to do these, I want you to write the u plus v first, because chances are it's going to be the case. Your u plus v is not going to factor. So you can see that this 4x squared plus 9 is just brought down. However, 4x squared minus 9, being that it's a perfect square, it'll factor one step further. So our final answer becomes 4x squared minus 9 times 2x plus 3, 2x minus 3. The 2x and the 3 are, of course, the square root of 4x squared and 9, respectively. A perfect square trinomial is the square of a binomial, and it has the following form. U squared plus 2uv plus v squared will factor into u plus v squared. And notice that I pointed this out earlier, the first sign, because this middle term is positive, my answer has a positive sign. And if that middle term was negative, then the answer would have a minus sign there. Note that the first and last terms are perfect squares, and the middle term is twice the product of u and v. Let me go back. I need to go down to the bottom of this page. Perfect squares. The next two formulas show the sums and differences of cubes. Pay attention to the signs of the terms. Again, I'm going to write it down. On the first one, we're finding it's the sum of two cubes. So we have same sign, opposite sign, always plus. That gives you that SOAP. And if you have a difference of two cubes, it's still same sign, opposite sign, and always plus. Trinomials with binomial factors. To factor a trinomial of the form ax squared plus bx plus c, use the following pattern. Okay. The leading terms will be factors of my leading coefficient. The last term, change colors here. The last term will be factors of C. So when we're doing this, the goal is to find a combination of factors of A and C, such as the outer and the inner products add up to the middle term B. When multiplying, if you have the trinomial 6x squared plus 17x plus 5, you can write all possible factors and determine which one has outer and inner products that add up to 17. So if we're looking at it, how do we get 6? Well, 6 comes from either 6 times 1 or 2 times 3. And that's the only two ways that I can get 6. They also showed another 6 times 1 and another 2 times 3. Well, what about ways of getting 5? There's only one way to get 5, and that's either 1 times 5 or 5 times 1. So we have a 5 times 1 here, 1 times 5, 1 times 5, 5 times 1. And so if we did this with trial and error, and we step back and look at it, we're like, okay, so every one of those will give me the 6x squared. Every one of those will give me a 5. Well, which one gets me the 17? So the only way to get the 17 to look at is the fact that, well, let's look at the first one. The first one, if I had 6x and 5x, well, 6x and 5x is only 11x. That's not what I want. This one here, that's 30x, and this is 1x. That gets me 31x. That's not 17 either. The next one, the outers, that gives me 10x and 3x. Well, 10x and 3x is 13x. And the last one, 2 times 1, that's 2x. 5 times 3, that's 15, 15x. 2x and 15x is, in fact, 17x. So this is the only one, when I multiply them together, I'm able to come up with that middle term of 17x. So that tells me that my initial trinomial, 6x squared minus 17x plus 5, will factor into 2x plus 5 and 3x minus 5. Trial and error. All right, I'm going to go ahead and go back to this trial and error problem real quick. And we're going to look at it with something that I call the box method. All right, so the box method is a process of factoring a trinomial such that the leading coefficient is not 1. So here's how this works. I'm going to take 6x squared plus 17x plus 5. And the first thing I want to do is realize what the product of a times c is. So remember, a quadratic is ax squared plus bx plus c. So when I look at a times c, 6 times 5 is 30. And I see that my middle term is 17. I want to know what two numbers will give me a product or multiply together of 30. However, I want those two numbers to give me a sum of 17. So instead of writing all this guess and check out, I'm just going to look at it and just talk about the numbers for right now. Well, how do you get 30? Well, you can get 30 by 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And those are the only ways. If you want to be picky, yeah, you could say 30 times 1, and 15 times 2, and 10 times 3, and 6 times 5, but obviously I'm repeating myself. So since all of this problem has to do with adding, I want to know which set of the numbers over there will give me a 17 if I put them together. Well, the first group gives me 31. The second group gives me 17. Then we have 13 and 11. So what I'm going to do is I'm going to rewrite that polynomial. Instead of writing 6x squared plus 17x plus 5, I'm going to break that 17x up. And I'm going to break it up using the numbers 2 and 15. So I have 6x squared plus 2x plus 15x plus 5. Now looking at that, I have 4 terms now. Looking at the first 2 terms, what can I factor? This is called factoring by grouping. We'll talk about it again in a little bit, but when we get to it here in a little bit, I'm going to fly through it a little faster. But you can tie that, when we get to the grouping part, you can tie that back into what I'm doing now. So what do the terms 6x squared and 2x both have in common? Well, they're both even. The biggest number that goes into 2 and 6 is 2. And they both have at least an x. And that's all I can factor out. So I'm going to take a 2x out of 6x squared plus 2x. Doing so, 2x times, well, 2 times 3 will give me the 6 back. And x times x will give me the x squared back. 2x times what will give me my 2x back? Well, if I factor a 2x out of 2x, I'm left with a 1. Don't fall into that trap of saying, well, I factored 2x out, so there's nothing there. No, that's not true. Because remember, if you factor something out, you must be able to multiply it and get back what you started with. So 2x divided by 2x is 1. My next 2 terms are 15x and 5. What do they have in common? Well, the only thing I can factor out of that is a 5. And because my first term here is positive, I'm going to take out positive 5. By doing so, I'm left with 15 divided by 5 is 3. And there's an x plus 5 divided by 5 is 1. And if you recall the problem worked a while ago, that was 2 weird looking terms. If you'll notice, these 2 terms both have a 3x plus 1. So I can actually take, bring it over here, right? So I can actually take the 3x plus 1 out of both of those. So 3x plus 1. And again, if we're ignoring this guy because we factored it out, and we factor this guy out, all that's left is this 2x plus 5. So 2x plus 5. And there is the exact same answer we got below. It's okay if it's written one way or the other. It doesn't really matter. All right. Factoring a trinomial when the leading coefficient is 1. Okay, when the leading coefficient is 1, we're still going to kind of do the same thing we just did a minute ago, but doing the whole grouping thing is actually extra work. Because we're worried about a times c. Well, when a is 1, we're just going to get C, right? So A is 1 right here. So because the leading coefficient is 1, it's going to factor pretty easily. So because B is negative and C is positive, both factors of 12 must be negative. So the only way to multiply, there's two ways to multiply two numbers together to get a positive answer. A positive times a positive could give you a positive 12, or a negative times a negative could get you a positive 12. So because that middle term is negative, I know I'm dealing with a negative and a negative. So how do we get 12? Well, 1 and 12, 2 and 6, and 3 and 4. And that's it. That's the only three ways of getting 12. Looking at those groups of numbers, which one will get you a 7? Well, 3 and 4. But remember, we're doing negatives between -3 and -4. So if you'll notice, this -3 is right here, and this -4 is right here. So it factors very easily into x minus 3, x minus 4. Factoring by grouping. This is what I did a minute ago when I was showing you how to break that thing up into factoring by grouping. Sometimes polynomials with more than 3 terms can be factored by grouping. So typically, if you have more than 3 terms, you have 4 or more, a method you might look into to see if it's possible is, can I factor this by grouping? So if I had the polynomial x cubed minus 2x squared minus 3x plus 6, you can see that the first group is x cubed minus 2x squared. And I'm just going to work through this problem real quick with just those two. So if I have x cubed minus 2x cubed, what do they have in common? Well, the coefficients are 1 and 2, so only 1 comes out. They both have x's. The first one has an x cubed, and I have an x squared. So I know I have to have an x. The smallest exponent is 2, so I'm factoring an x squared out. If I take an x squared out of x cubed, I'm left with x. If I take an x squared out of minus 2x squared, I'm left with minus 2. The other pair is minus 3x plus 6. And notice what they did. They took that minus sign and kind of pulled it away from both the 3x and the 6. When they did that, that minus 3x became a positive 3x, and that 6 became a minus 6. So here's what I have. I'm now factoring a 3x and a minus 6. What do they have in common? Well, I can take a 3 out. If I take a 3 out of 3x, I'm left with x. If I take a 3 out of a -6, I'm left with -2. And just like before, I look at this guy and say, okay, I now have 2 terms. Both of those terms are kind of messy, but both of those terms have an x minus 2 in common. So I can take that x minus 2, factor it out. And when you ignore the x minus 2s, all that's left is x squared minus 3. And using simple numbers, x squared minus 3 does not factor. We are subtracting. It is x squared minus 3, but 3 is not a perfect square, so we are in fact done. And that's factoring by grouping. Factoring by grouping can save you time of the trial and error involved in factoring a trinomial. To factor a trinomial of the form ax squared plus bx plus c by grouping, rewrite the middle term using the sum of the 2 factors of the product AC that add up to b. So step number 1, factor out common factors. Always, folks, anytime you're factoring, step number 1, factor out the common factors. Step number 2, factor according to one of the special polynomials. Number 3, factor as ax squared plus bx plus c. Number 4, factor by grouping. Okay, so I've went over all the factoring rules, and now we're into the practice problems. So we have several practice problems that I'm about to work. My recommendation for you is to go ahead and stop watching this video at this time. Work the practice problems yourself, and once you're done working the problems, come back to the video, and I'll be able to show you me working them out. Again, Just because I do it a certain way does not mean that's the only way to do it. If you got the right answer and you didn't violate any math errors, and that's okay. You might want to talk to me to make sure that, does this always work, or did I trip into the answer? But there we go. That's what we're going to do. Number one, factor out the common factors. So as I look at number one, I see coefficients of 2, 4, and 6. Well, the biggest number that goes into 2, 4, and 6 is a 2. So all of them have a 2 as a factor. And I look at variables, and all of them have z's. I have z cubed, z squared, and z. So I can factor out a 2. I can also factor out the z. All right. The exponents on my z's are 3, 2, and 1. The smallest exponent is a 1, so all I can factor out is a z to the first power. Sometimes it helps you when factoring is to ask yourself, okay, take what I started with, divide it by what I'm factoring out. 2z cubed divided by 2z. Well, 2 divided by 2 is 1, and z cubed divided by z is z squared. Next one. Negative 4 divided by 2. Negative 4 divided by 2 is negative 2. Z squared divided by z is z. And the last one. A positive 6 divided by 2, that would be a positive 3. And z divided by z is just 1. So it cancels out. We're good to go. And there's your answer. Number 2, factor out the common factor. I have 2 factors here separated by an addition sign. Those 2 factors have an x minus 5 in common. So I'll factor out an x minus 5. When I factor out that x minus 5, kind of pretend they're gone, all that's left is 3x plus 6. And all this problem said to do is factor out the common factor, okay? So if all I'm doing is factoring out the common factor, folks, I did do what it asked. I'm not particularly fond of this problem because when I look at this problem, I look at this last term and I notice that 3x and 6 both have a 3 in common, which means I could factor a 3 out of that 3x plus 6. If I factor the 3 out, I'm going to write that 3 all the way at the front because this is just one thing multiplied together. I'm actually going to write that 3 down way over here. Here is my x minus 5. And because I factored a 3 out of 3x plus 6, I'm left with x plus 2. Okay? And so that would be actually factored complete. But all it said was to factor out the common factor. When you do your homework, it might accept this first answer as being correct because you are in fact doing the factoring out the common factor. But in my personal opinion, that right there would be the correct answer to this problem. That would be factored completely. Number 3, completely factor the difference of 2 squares. So I look at this problem, and the first thing I see is a 63. Well, I'm not a rocket scientist or anything, but I'm pretty sure that 63 is not a perfect square. However, if that's what you're looking for first, you've messed up because the very first thing you must always do when factoring is look for a greatest common factor. Okay, so first thing I want to do is I'm going to go ahead and write this one in what's called general form. General form means my exponents are in descending power. So I'm going to rewrite this as negative 28 x squared plus 63. And now when I look at that, it's like, 28 and 63. 7 goes into both of those. So I'm going to factor out a 7, but because my leading coefficient is negative, I'm actually going to factor out a negative 7. If I take out a negative 7, I'm left with positive 4x squared minus 9. And folks, that's a good thing there because when I wrote it in general form, I no longer had a difference of 2 squares. But as soon as I factored that negative out, it became a difference of 2 perfect squares. All right, next step, keep that negative 7. I've seen people many times when they factor out some greatest common factor at the beginning, all of a sudden they drop it, don't write it anymore. Remember, that is still part of the answer. Okay, so 4x squared. 4x squared is a perfect square. It came from 2x times 2x. So 2x squared is 4x squared. The 9 came from 3 times 3, which would be 3 squared. So my square roots of 4x squared and 9 would be 2x and 3. Those are the numbers I'm going to use. So I have 2x plus 3 and 2x minus 3. And I look at that answer, nothing else factors any further. That is my final answer. All right, number 4, completely factor the difference of two squares. 2,401. Well, I'm going to assume that's a perfect square, otherwise they wouldn't give that to us. U to the 4th. U to the 4th is a perfect square because u squared times u squared is u to the 4th. And of course, 1 would be 1 times 1. The square root of 2401 is 49. So this came from 49u squared, and this guy came from 1 squared, which means 2,401 u to the 4th minus 1 factored turns into 49 u squared plus 1 times 49 u squared minus 1. Am I done? And the answer is no. And the reason I'm not done is because 49u squared is a perfect square. It came from 7u. And 1 is a perfect square. It came from 1. So again, the reason we write down the plus first is because it does not factor any further. So I'm going to bring it down, 49u squared plus 1. And factoring 49u squared minus 1 factors into 7u plus 1 times 7u minus 1. And that one is completely factored. Next page. Factor the trinomial x squared minus x minus 72. Now for this particular problem, my leading coefficient is a 1. So because my leading coefficient is 1, I still want to know what two numbers multiply together. Of course, a is 1, b is negative 72. What two numbers multiply together to give us a negative 72? That's going to be our product. And my b is negative 1. That's going to be my sum. So what two numbers multiply together to get negative 72, but combine to get negative 1? Well, to multiply two numbers and get a negative answer, that tells me that one number is positive and one number is negative. To combine two numbers, one of which is positive and one of which is negative, and get a negative answer, that tells me that the absolute value of the bigger number is negative. Or I can say in quotes, the bigger number is negative. So how do we get 72? There's quite a few ways. We got 1 and 72, we got 2 and 36, 3 and 24. 4 goes into it, but 18 times. 5 doesn't. 6 does 12 times. 7, no. 8 does 9 times. Okay. And so when I look at those numbers and ask myself, okay, well, how in the world will I combine those two numbers, one of which is negative, and get a negative 1? Well, that tells me that they're going to be 1 apart. So the only way to make that happen would be 8 and negative 9. 8 times negative 9 is negative 72. 8 plus negative 9 is negative 1. So folks, I'm done factoring. The answer is x plus 8 and x minus 9. So when a is 1, it's just going to be the variable and the two numbers. The variable and a positive 8, the variable and a negative 9. Number 6, factor the trinomial 3x squared minus 2x minus 16. Okay, earlier in this video, I showed you a method of doing this where we end up doing a factoring by grouping. You can go back to the video and look at that process and follow that if you want to. I'm going to go ahead and show you another method here. This method is called the box method. And it's really doing the same thing. It's just a way of writing it down that will possibly help you organize your thoughts a little better. It's going to start off the same way. I need two numbers that multiply together. In this case, AC is 3 times negative 16. 3 times negative 16 is negative 48. So I want a product of negative 48. And B is negative 2. So they have a sum or combined to negative 2. And we can go through the process of listing all those numbers, 1 and 48, 2 and 24, 3 and 16, 4 and 12, and then you get to 6 and 8. Well, here we go again. Let's talk about our signs. If I have to get a negative 48, well, to multiply two numbers and get a negative 48 tells me that either the 6 or the 8 has to be negative. Well, which one? Well, to get a sum of negative 2 tells me that the bigger number, not really bigger because it's going to be a negative number, the bigger number is going to be negative. So if I combine a 6 and a negative 8, I will get negative 2. Okay, so here's what that box looks like. I'm factoring a trinomial. I'm breaking that into 4 pieces, just like I did with grouping, but I'm kind of organizing it in a special way. When you're making this box, make sure you have space on the left and on the top to right because you'll need those spaces. We're now going to take 3x squared minus 2x minus 16 and put it in this box. But that's only 3 terms, but I have 4 boxes. Okay, first term, first box, always. So my first term is 3x squared, it goes in the first box. The last term, last box, always. So minus 16 here. And if you remember when we did the grouping a while ago, we actually took that middle term, in this case negative 2x, and broke it into 2 pieces. We're going to call this one 6x and negative 8x. And folks, I can put those in either box. I could put the negative 8x here or here. It doesn't matter. Okay. I'm going to put, because my bottom left box is small, I'm going to put the 6x down there, and I'll put the negative 8x in the top right box. And now what we're going to do is factor rows and columns. If you remember back in the P3 video, if you watched it, this is how I actually multiply binomials. I put a binomial on top, a binomial on the left side, and I filled in the multiplication table. What I'm doing now is I've got the multiplication table already built, and I'm going to take out the stuff to see what we're going to get. So let's look at this first row. My first row has a 3x squared and a negative 8x. The only thing those have in common is an x. On my second row, I have a 6x and a negative 16. Well, the only thing I can factor out of 6x and negative 16 is 2. Let's go by columns now. My first column, 3x squared and 6x, I can factor a 3 and an x out of those. And the second column, I have a negative 8x and a negative 16. The only number that goes into those would be what? 8. So I'll put an 8 there. Okay. But look at the box closest to the 8. The box closest to the 8 says negative 8x. So instead of this being a positive 8, it's going to be negative 8. And folks, it's factored. The answer is right there in front of us. I don't care which one you write down first, the top or the left, but you write them down. So this factors into 3x minus 8 times x plus 2. Okay, so just notice I kept whatever sign was there, I kept it there. So I had to put a plus in front of this 2 to put those together. And if we were to FOIL this, first times first is 3x squared. Outside times outside is 6x. Inside times inside is negative 8x. 6x minus 8x is negative 2x. And last times last, negative 8 times 2 is negative 16. So it is factored. Number 7, 25x squared minus 30x plus 9. factoring. First thing I want to do is look at it and ask myself, is there anything that I can factor out of all three of those terms? Well, the only thing that goes into 9 are 1, 3, and 9, and 3 and 9 don't go into 25, so no, it doesn't. So here we go. AC, A times C, 25 times 9. 25 times 9 is 225. B is negative 30. Notice, A, my first term is 25x squared. That's a perfect square. 5x times 5x is 25x squared. Last term, 9. 3 times 3 is 9. That's kind of interesting. My first term and my last term is a perfect square. So it kind of makes me start thinking, is there something special about this? Well, if I took 5x times 3, I get 15x. If I double 15x, I get 30x. But this middle term is minus. So folks, this is going to factor into 5x minus 3 squared. So that's factoring it using the perfect square properties. But let's say we didn't see that. Let's go back to my whole A, C, and B. Well, two numbers that multiply to get 225, but when I add them together or combine them, I get negative 30. Well, that would be 15 and 15. 15 times 15 gives me 225, but 15 plus 15 gives me a positive 30. So let's change the signs. Negative 15 times negative 15 is also 225. Negative 15 plus negative 15 is negative 30. So if I was going to do the box on this, remember, leave space on the top, leave space on the left to right. First term, first box, 25x squared. Last term, last box, 9. We're breaking up that negative 30x into two pieces, negative 15x and negative 15x. My first row, what do they have in common? 25x squared and negative 15x. I can factor a 5x out of that. Negative 15x and 9, I can factor a negative 3 out of that. Going down, 25x squared and negative 15x, I can factor out a 5x. Going down, negative 15 and 9, I can factor out a 3, but because the box closest to it is negative, it's negative. And notice I got 5x minus 3 times 5x minus 3. And the better way of writing that, since it's the same thing twice, would be 5x minus 3 squared. So again, if you recognize some of those properties of perfect square trinomials, it's going to help you. It's going to save you some time. But if you don't, this box method is going to work for you. Number 8. Number 8 tells me that we have a sum of cubes, and they gave us some big numbers there. 729t cubed, that would be 9t to the third power. And 125, that would be 5 to the third power. And we're adding here, and go back to our property. Our property said that u cubed plus b cubed equals the first guy plus the second guy times the first guy squared, opposite sign, the product of those both of the guys, so UV, always plus the last guy squared. Well, what I did at the very beginning, right here, is where I identified U and V. So my U is 9t and my V is 5. So I'm going to write the answer. We have 729 U cubed plus 125. That's going to equal, my U is 9t plus my V is 5 times u squared. Well, my u is 9t. 9t times 9t is 81t squared minus u times v. 9t times 5 is 45t. Always plus v squared. My v was 5. 5 squared is 25. And there it is. And our last slide here, factor the trinomial. I need to factor negative 7y squared minus 24y plus 16. It is in general form. My powers are decreasing, but if you'll notice, my very first coefficient is a negative. When factoring, you really want your coefficient, your leading coefficient to be positive. So what I'm going to do is I'm going to factor out a -1, which means I'm going to take a negative, pull it out to the front, and change the signs. So I've got a negative parenthesis, 7y squared plus 24y minus 16. Well, to factor this, I need to find out what AC is. So we got 7 times 16. So AC, but it's a negative 16. So AC is negative 112. My B is 24. I need a product of a negative 112 that combine to 24. So what could those numbers possibly be? Ways of getting 112. 1 times 112, 2 times. So we're going to go on for quite a bit here. Just going to kind of enter this in the calculator so I can get some numbers for you real quick. 4 and 48. So 4 times 48 is negative 112. To be negative, 1 has to be positive and 1 is negative. That doesn't combine to 24 though. Keep going here. Combine to a positive 24. Yeah, that's right. Because it's not a 48. Sorry, guys. It says a 28. Okay, so 4 times 28 is negative 112. But I want a positive 24 out of that, which means the bigger number is positive. So 28 is going to be positive and the 4 is going to be negative. Don't forget that negative is going to be part of my answer, okay? So I'm going to go ahead and mark a box over here, give myself some space. First term, first box, 7y squared. Last term, last box, negative 16. I want to point out again, as I'm doing this, I'm not using this original problem. I'm using the problem after I factored out that negative sign, okay? I'm going to break up the 24y. I'm going to break it up into a negative 4y. And a positive 28y. Go on across 7y squared and 28y. I can factor out a 7y. Go on across negative 4y and negative 16. I can take out a 4. But because the box closest to the 4 is a negative, that's going to be a negative 4. Going down 7y squared and negative 4y, I can take out a y. Going down 28y. And negative 16, I can take out a 4. And that 4 is positive because the box closest to it is positive. And there are my factors. So my final answer is going to be negative. That's the negative that I factored out. I have 7y minus 4 times y plus 4. And that is completely factored. And finally, number 10, last problem, factor by grouping. Normally when you're doing grouping, you want your problem to be in general form, which means descending powers, and it is. 4x cubed and x squared, all they have in common is an x, and the smallest exponent is 2. So I'll put x squared. When I take that x squared out, I'm left with 4x 4x times x squared is 4x cubed plus x squared divided by x squared is 1. Second pair, I have a negative 28x and a minus 7. Well, those both have a 7 in common. However, the leading term there is a negative 28, so I'm going to factor out a negative 7. Negative 28 divided by negative 7 is 4, and there's my x. Negative 7 divided by negative 7 is plus 1. Looking at these two terms, what do these two terms have in common? They both have a 4x plus 1. And if I take out that 4x minus 1, the only thing I see left would be x squared minus 7. Okay, x squared is a perfect square. We are subtracting. 7 is not a perfect square. That is not a difference of two squares. It does not factor. And guys, that's it for this section. I'll stop this video now and I'll record another one in just a little bit. Have a great day.